Hey, my name is Andre, and in this video I'm going to show you how you can use Chainlink Local with Hardhat on a forked development environment. So if I scroll down over there, you already learned about it. This is the link to the local documentation, Chainlink Local documentation, and you can find it over here. And by clicking, you'll find the Chainlink Local documentation page. If I go to API reference, I can see that with Chainlink Local, I can use CCIP Local Simulator as well. This is a smart contract that can be used with Foundry, Hardhat, and Remix ID in a localhost environment. Then there is CCIP Local Simulator Fork as well contract, which can be used with Foundry, and CCIP Local Simulator Fork.js file, which can be used with Hardhat. This is for forking features. And it exposed three basic API methods to request link from faucet, get EVM to EVM message, and route message. We're gonna see that in a bit, how to use those. So if we click here, we can see the simple usage of CCIP Local Simulator Fork.js with Hardhat. So one important thing to notice is when you run this, make sure to set the network flag to localhost or make localhost as your default network in a hardhat.config file. Over here, you can import these three functions from the Chainlink Local package like this. So Chainlink Local scripts CCIP Local Simulator Fork. This is how you can use it. And then it's important. So in the first terminal, you need to run npx hardhat node. And in the second one, you'll run your script with the network flag set to localhost. And you can see manually, you can actually see in your first terminal in an npx hardhat node how it executes a bunch of stuff. Okay, cool. So to use Chainlink Local on multiple different fork test networks, you'll first need to create fork networks. So to do that, you'll need RPC URLs for your testnets. In here, I have Ethereum Sepolia and Arbitrum Sepolia, but you can use different one, of course. And that needs to be RPC URL to the archive node. So the best thing is to just use Alchemy. They have archive node support, so Alchemy is really good for forking with Hardhat. Then this piece of code is basically switching between networks to networks, okay? So by doing Hardhat reset, we are erasing the localhost state to blank state, and then we making a copy of that provided network in this provided block number. Important thing to notice is when you switch networks like this, you are not aware of previous state. With Foundry, we were able to do that, but here with Hardhat, we will need to redeploy our contracts. I'll get to that in a minute. So by doing Hardhat reset, I'm currently on Ethereum Sepolia RPC URL. I'm here. I can request link from faucet. I can deploy my sender contract, etc. Here, I can actually start on Arbitrum Sepolia RPC URL, so Hardhat reset Sepolia, and then deploy receiver contract, then reset. Now I'm on Ethereum Sepolia, deploying sender contract, sending the CCP transaction. We'll go to that in a minute, and then again reset, going back to Arbitrum Sepolia. Now we will need to redeploy our CCP receiver unsafe contract once again, because we are starting from a blank state. So this state now does not have no knowledge about the receiver contract before. But the thing is that if you do that in the same sequence, then the addresses will be actually the same because of the create opcode and create do, etc. So it's advisable just to have a script which will all do this setup functions all the time you switch to a different network. And when we're sending a transaction, it looks like this. So request link from faucet, just requesting links, transfer links to your sender contract or to whatever the target address is. Then we will need the received. So in a Foundry forking environment, we're basically listening for all events and searching for the CCP request sent event. Here, however, we can actually get that event much quicker from the transaction received. So we're here gonna create a transaction object, call the send function, which is the one we actually used from the previous videos, and then wait for that transaction to be included in the next block so you can get the receipt. Now you'll just provide that receipt to get EVM to EVM message, and that's it. Get EVM to EVM message will filter that received for a CCP CCP request send event, which is important for us. And then it will, from that event, will extract the EVM to EVM message you sent and just return it to it. And finally, when you switch to a different network, you will call the route message function here, provide the address of a router on that particular blockchain and the EVM to EVM message you get. And then route message will will use the router contract, use that message and route that message to the correct receiver. So it will get all the details about the receiver, about which lane to use, etc. from the EVM to EVM message object itself. And that's how you can use it. The good thing about Chainlink Local is that you have examples folder over there. So if you go to examples, you can find a bunch of other examples. And here you can see how you can use this example in Hardhat. So again, you will need to git clone Chainlink Local for this one to run. This is how you can run it, but we are interested actually today in the code itself. So run a node, run a script. Here we are on Arbitrum Sepolia. We are providing addresses of a router and a BNM tokens, and then just deploying the CCP receiver unsafe. Plus we're in creating an instance of CCP BNM token on Arbitrum Sepolia as well, so we can console log the address of a receiver before sending the cross-chain message, so we can compare that later. Then we are on Ethereum Sepolia. We saw already that, so we are creating a CCP sender contract here, funding it with links from Faucet, console logging the balance of CCP BNM before sending the cross-chain transaction and after. And here we are actually sending the cross-chain transaction and getting the receipt over here, which we needed. From the receipt, we get the EVM to EVM message. And after that, we are back on Arbitrum Sepolia. We'll just redeploy CCP receiver unsafe to have it on this new state and route message. After that, we can console log the text we received, which is hello world in our example, and then console log the balance of CCP burner main tokens afterwards. And that's how we can use Chainlink Local with forking feature in Hardhat. Thank you for watching.